Hello and welcome to the Cyber Focus Day. I'll be talking to you about modern day artistry, painting stories with Windows artifacts. I'm Fernando Tomlinson. A little bit about myself. I've been with the Department of Defense for about 19 years. I started my career off within the DoD doing IT support, moved on to enterprise admin, and then I made a shift into cyber about 7 years ago. I was doing incident response, and then I found myself doing vulnerability assessment, pen testing, and now I do forensics and malware analysis for United States Army Cyber Command. I'm a cybersecurity adjunct professor where I teach Python and PowerShell. I'm a developer of various blue and red team tools, and where I can bring them outside of my work, I like to post them on my GitHub for the community. I'm the co-author of the PowerShell Conference Book Volume 2. All proceeds from that book goes to underrepresented, underprivileged individuals trying to get a start in cybersecurity. I do have a presence on the internet. You'll see a couple of sites in which I have some stuff at. Okay, so our agenda for today, as we dive into this, largely speaking, we're going to be talking about the registry and the event logs, all very Windows centric. This talk will teeter upon some defensive type artifacts, some offensive type artifacts, and then somewhere in between, you'll be able to discern which one makes more sense for you based upon what you're doing. Okay, so with that, I'll kind of jump into my disclaimer. And the disclaimer is a TLDR, if you will, too long didn't read, but it's also a TSCR, which is too small couldn't read. So let me sum this up for you. This presentation is not suggestion to only bypass or only analyze the registry or event logs, but I'm merely highlighting the small amount of the plethora of data that you could get from looking at these areas. All right, so what is the registry? Well, at large, the registry is the DNA for a Windows operating system. It's a central hierarchical database in which data resides. Much of this information speaks to what software is installed, the hardware that's connected, user preferences, operating system configurations, and a lot more of data. Now, this is essential in the sense that from a forensics perspective, this is a goldmine of information. The registry is really broken down into two parts. Now, we have the part that's resident on our disk, the hives themselves, and then what they form into when they're loaded into memory. All right, so when we talk about registry hives on our disk, we're talking about default, SAM, security, software system, and all of them are located in our Windows directory System32 config. About every 10 days or so, these hives are backed up and they're placed in that same directory in a new directory called regback. This is from Windows Vista and above. Now, from a user perspective, every user within their user profile has an ntuser.dat. And when that user logs in, that hive gets loaded into memory. They also have a user class.dat as well, and that user class.dat is going to help track things like program execution and also articulate files and folders that the user actually interacted with and attempted to open. Okay, so looking at these things from disk to memory. Again, they're all resident on our operating system, our system. When we have some process that happens, either Windows boots, starts up, or a user logs in, the applicable hives get loaded into memory and they get formed into new hives that we come accustomed to calling them as. And these things are this, right? So ntuser, user class, when a user logs in, it gets loaded into memory and then gets known as HK current user. That is the current user who's logged in. And then SAM security software system gets loaded into HKLM, local machine. Well, then we see a number of other hives that are there. And largely speaking, the HK users essentially becomes users that are logged in, but are no longer the primary user. So think of, the Windows capability where you could switch user. You're not actually logging a person out, but you're moving their profile, if you will, to the background. And that's where that user's ntuser.dat gets loaded at that time. The HK current config is simply a pointer to other aspects within the registry hive themselves. Okay, so from a visual perspective, when we open Registry Editor, we see something like this. We have our registry keys and subkeys on the left-hand side, and then off to the right for each one of those keys and subkeys, you might have value and then value data associated with them. Again, our keys and subkeys are going to be on the left. The value and value data is going to be on the right. This is key for us to know and understand is, as you traverse the registry and you're trying to do some analysis amongst it. Right? Most of the data that's sitting in the registry needs to be converted into some type of human readable format for us to make sense of it. That's in the sense of some of the stuff is stored as binary, other parts are stored as XML, some are stored in a form of encoding, ROT13, where they do some character shifting. So that way, if we found ourselves trying to search the registry for human readable strings like Fernando, depending on where that data sits, it could be ROT13 encoded with those characters shift to the right. The time in which is associated with the last write time on these things are in Windows 64 bit time, which is essentially nanoseconds since January 1601. Okay, so why the registry for analysis? Well, on top of it being a goldmine of information about the system or user activity, we also get things associated with the operating system and applications that are installed. And it's just not for malware investigations, i.e. did something execute, did a user do something, but we can also store malware stagers in the registry as well. So the registry at large, if you're an analyst, defensive in nature, what can it do for you? Well, here's a couple of things it can answer for you. Did malware or something suspicious actually execute? You can largely find some of that information, if not all that information, in the registry. How is persistence maintained? If it has something to do with the registry, you'd be able to get that in there. And what files and folders were accessed and how did they access it? Was it through command line? Were they interactively logged into the machine and they double clicked it? Was it a shortcut? We can get that information from the registry. And if we had to break this down into maybe an analysis perspective of the hives that are there and some other things that we can get from it, well, I kind of bucket it like this, where it's an evolving cycle, circular in nature, where I get something here, I transition here, which then has me transition there, and at some point I come back around, and it's a never-ending cycle of sorts. So when we look at the SAM hive, we can profile users. What users log in, what groups are they a part of, how often do they log in, how many times has their password been typed in incorrectly. From a system perspective, we can understand the setup of the machine, networks it's connected to, maybe time zones, services, installed programs, right? We can get all that information. The individual user themselves, well, we can see what files and programs they've opened, what things they've typed in. We can understand how they actually did it, going back to, did they double click it? Did they get referred there? What happened? Okay, so now you're starting to see the registry is great, although we haven't talked in the sense of artifacts, but to kind of start off, right, there's a number of tools, excuse me, that we can use to analyze the registry. We have Registry Editor, which is built into all Windows operating systems. It lacks the ability for us to be able to tell the last time a key was updated. We'll talk about how we can do that here in a minute. Reg Ripper, which is really, really awesome for us to be able to carve and really do analysis on the registry. It's extensible through a subset of plugins, so you can build plugins and modules to use with Reg Ripper. The bad thing is, if it's not in one of those plugins that you're looking for, you may not hone in on something. So if I write a plugin for a specific set of malware and you're looking for a different type and there's no plugin for that different type, well, you could be missing out on that. So we just have to be cognizant of that. Registry Explorer is going to allow us to do offline files. It is also great. And the big thing about it is that we can see deleted keys. So it's not uncommon for me or a malicious person to do some maliciousness, utilize the registry, and then guess what? Try to clean our tracks up. And through something like the registry editor, we wouldn't be able to see those deleted keys, but something like Registry Explorer, we would be able to. And then we have Yaru, yet another registry utility. It can retrieve deleted keys as well. It's awesome, but it costs a little bit of money, if you will. Registry Viewer, written by our friends over there at Access Data. Those are the same folks who wrote FTK, so solid product with this as well. And then we have PowerShell, where we can run this, or we can utilize PowerShell against these hives as well to kind of get after our task. So looking at some of these artifacts, when we look from the perspective of execution, we have MUI cache, and this is going to store information about new products or new applications that were launched. There's no program execution time associated with it, but we could discern whether something was executed or not by looking at this artifact. Shim cache is another great thing. It's really used to identify application compatibility challenges within executables, but we can get information such as file name, the path, the size, the last modified time, the last execution time. These are all great things that we'd be able to get from it. The only bad thing about it is this doesn't get written to until the system shuts down, right? But if we absolutely need it, we can dump memory and we can do analysis from there. So my screenshot down below, we see that we're looking at the MUI cache, and we start to see those applications that are launched from a human readable perspective. Okay, we also have User Assist. User Assist is going to track executables that were open in Windows Explorer. So think of the File Explorer window, if you will. We get last time, number of times that the application was launched. This data is stored in ROT13, so we need to be able to develop something very quickly to make sense of it, or we can use some third-party tool that would do it for us. We got recent apps, and this is something that's somewhat new for Windows 10. It's going to track applications and programs that were launched within File Explorer. This is going to be similar to User Assist in the sense of what it gets. This is great because since this is somewhat new, I say that loosely, somebody trying to wipe their tracks may automatically go to User Assist, but they may not think to do something in recent apps. We have Shellbag. Shellbag is going to contain the path and last write time of every folder accessed. This is going to help us determine kind of the structure and access volumes. It also shows us how they did it in the sense that it requires interaction with the shell. So that's useful in that aspect. Recent docs is going to show us things that they opened via File Explorer, track the last 150 items open. And when we look at recent docs, oh, sorry, I thought it was the next screen. When we look at recent docs, again, File Explorer. So think of that window up top. We have the MRU cache, most recently used list rather, and this is going to show us based upon applications, what files, what items were open. We have Word World Query. This is also going to be able to show us from that File Explorer search bar. So we're able to tackle this from two parts, right? Because we talked about the recent docs one a minute ago. Now we have Word World Query, and then we have artifacts in both locations. When we look at what programs are installed, we can get this from the uninstall key within HKLM. It shows us by program what's installed, when it was installed, version, the path to it, all of that good stuff. So we don't necessarily have to look somewhere else. We can get all of that from the registry. And what's interesting, again, this is going to be for the local machine, but as we were talking about things that were searched in File Explorer and most recently used, you'll notice it begins with HKCU where that's stored. So that screams that it's for the individual user and not for the system at large, whereas HKLM would be for the system at large. Here's another one that's specific to the user. We have typed URLs. So gonna track the last 25 typed URLs or file paths that were typed within Internet Explorer or File Explorer. So yet another artifact from File Explorer. And if somebody were to go in and wipe this key, then yes, it would wipe that information as well. Now, one limitation to this is if somebody was navigating within Internet Explorer to a site that's in their favorites, it doesn't get logged here. So we just need to be cognizant of that. We have typed paths. Again, another artifact specific to an individual user. This gets written when the user is logging off. So if we need to access that beforehand, we would dump it out of memory. But we're talking things that the user is actually typing. So during an investigation, we can say, hey, the user copied and pasted, the user typed this in, and here becomes another artifact of that. As users have their daily activities, they might map drives. So here's where we'd be able to see what drives a user has mapped. This could be indicative of a place that an actor who compromised the user was then able to laterally move. It could just be indicative of normal activity, but we'd be able to see what's set up for the individual user. All right, so with typed paths, we see within our file explorer that we have demo.dll and we have GitHub already in there. And then when I go look at typed paths within the registry, I see both of those items already listed there. Again, artifacts for individual user perspective. From a persistence perspective, we have things like the run keys. These are good old faithful keys. When I look at the run keys, they're set to when either the user logs in or when the system boots up that a specific thing may kick off. Those are well known, but still utilized, right? But then we have things like application hijacking. So we understand where DLLs are set to kick off from. We can then get our DLL written to that location and then take advantage of a specific APIs that are calling upon these DLLs to then run our DLL when we need it, right? So that becomes a form of persistence. We have browser helper objects, and these browser helper objects are also DLLs that are being utilized by the browser. Again, if we can get a malicious DLL in a place in which these browser helper objects are calling upon the DLL, we can get malicious code loaded. All right, going back to the run key. So we have a persistent run key that never change. We have a run once key that anything that's listed there, it will run that item once and then it would delete it from the run once key, i.e. runs once. So somebody could have a log on script or log off script rather, and as the user is logging off, it creates the item in the run once key. So now when the user logs back in, run once or whatever's in there executes and then deletes the artifact. And then when the user goes to log off again, it creates the run once instance and that cycle continues on, right? Another way that somebody may try to utilize the run key, but in a little bit more stealthier manner. And there are many, many ways within the registry for somebody to persist. So here's us trying to take advantage of a user that's not logged in. So utilizing a little PowerShell here, we're going to create a new PS drive. And essentially, we're going to create this to HK users. This is just going to be a place where we're going to do our bidding in our maliciousness. We're going to load a user's hive. This user is called Nandy. He's not logged in because if he was, then his NT user would be locked and I wouldn't be able to access it. So I'm going to access his ntuser.dat from his profile. I'm going to load it into my current session. I'll load it under HK users, not current users, and I'll load it as 1, 2, 3. From there, I'll create a new key within software and I'll call it evil key. Once I'm done, I'll then create a value called totally legit. I'll do that in the run key and I'll have a value of boom.exe. Instead of it being straight up boom.exe, in theory, I would have given it the full path so it knows where to execute it. After that, I'm going to clean up my mess and unload his registry hive. So now when the user Nandy logs in, he has this key that I created called evil key. It doesn't do anything, but more importantly, I created some persistence in his run key that's going to run automatically when he logs in. So going back and looking at an investigation, one may find this and be like, oh, okay, this user was compromised. How did it get compromised? Did it go to a specific site or something else? But no, instead, I loaded it offline through another compromised user. All right, from a base 64 perspective, we can do something like this. We can take a binary, convert it to bytes, a series of integers, and then convert those integers to base 64. We can put that base 64 in the registry and store it in the most obscure locations. There was a time where I did a talk at Microsoft, and I was talking to the room, and I was like, "Hey, the registry. This is where I would store data." And I was like, "Hey, I'm at Microsoft, the mothership, if you will. Is there somebody who can tell me about every registry key, right?" And I won't tell you the answer I got from it, but I felt very comfortable walking away from there that the registry is still a good location for me to use. Now, you may put some type of alerting on the registry when new things are added, and I applaud you for that. That's not the rule here, so I'll still take my chances. We call this fileless malware in the sense that it doesn't actually exist on disk. It's just a series of code that represents, or data, if you will, text that represents the malware itself. And aside from doing this in the registry, we can do this in Active Directory, event logs, alternate data streams, really anywhere that we can store data. Now, here's me taking just calculator and converting and going through that process. And what we'll see at the end is I'm converting that calculator to base 64, and I'm storing it in a key called software and another key called 7zip64. Within that 7zip64 key, I'm creating a value called updater64, and then I'm going to feed it my base 64 text. Now, why did I call it 64? Well, 7zip is legit, and if you really throw 32 or 64 or some combination of either of them off of something that appears legit, most people would just walk past it because in their mind they're like, it looks legit. Now, for me to get that data back and actually execute it, well, I'd reverse the process. So I'd call upon the base 64, convert it back to bytes, convert it to my actual binary, and then I would execute it. Cool. Now, let's say I have something like this, again, my base 64. When I'm done with it, I want to delete it. Maybe I've moved on to a different target. Maybe I no longer need this as an avenue. So this is largely the same. And at the end, you'll see where I'm doing remove item 7zip64. This is essentially me deleting it. All right, so now I go over to Registry Explorer. And from here, notice how on the left there, I see the key 7zip64 and it's got an X next to it. That's telling me that the key was deleted. Awesome. Now look to the right, or focus to the right, please. And you'll notice that I have the base 64 there. So I'm able to see the key that I deleted. I'm able to see the value and value data. And then down below, I'm able to see the last write time, essentially when I deleted it. So I'm able to get all of this from a forensics perspective, but I won't be able to do this at large across an enterprise. This is really artifacts that I'll be able to really hone in on when I'm drawn to a machine and I'm doing my analysis. So here's a couple more useful keys, and we'll look at this from the perspective of somebody doing malicious, that has a malicious intent, rather. Firewall rules are listed in the registry. So understanding where those rules are at, we can go in there and alter them. Maybe you want to delete them. Maybe you want to enable something that's disabled. Maybe you want to allow something that they're trying to block. We can do that in the registry. Or we could just outright disable the firewall altogether. If you're into PowerShell, you recognize that newer versions of PowerShell have a higher level of security built in, while the older version of PowerShell, PowerShell version 2, has no security built in. Most people seek to downgrade to that old version of PowerShell if it's on the box so they can do their maliciousness. Here is where that key is that either enables or disables it. Awesome. Some malicious folks like to use sysinternal, specifically PS exec, to be able to move from machine to machine. If you're doing this in an organization that doesn't use sysinternals, then you may be leaving an artifact. And here's the artifact. If you use any sysinternals tool, you'll recognize that right out the gate, it asks you to acknowledge the EULA. Well, once you do it once, it doesn't ask you again. That's because it writes to the registry key, as you see before you, saying that you've already acknowledged the EULA. So if I don't use PS exec in my environment, and now I'm starting to see this key is populated, this could be indicative of somebody maliciously on my box or what have you. So from a red team perspective, I'll just go in there and wipe that key, kind of getting rid of that artifact. So when logon is a critical process within Windows, and it deals with loading user profiles and a number of other critical things. Well, so by default in the registry, it seeks to load Explorer or US init. What we can do is we can append a binary for it to execute on top of that. This is an awesome place for persistence or for us to have things run. We're not really messing with the system. It's still going to do what it's there to do, but we're just having our maliciousness run behind it. So on the slide here, I have some brackets here with malware.exe. You would just put in the path to the malware or whatever executable you want to run. In modern versions of Windows, when we have 4688 event ID process creation, logging, it also gets the command line associated with it. That's very verbose and it's very helpful to a defender. From a red team perspective, I don't want to be helpful to a defender. So I'd look in the registry, understand if that thing is running, and I would just disable it. We see where that key is. Within Windows client machines, we have prefetch enabled by default. Prefetch is a very low-level artifact from somebody executing a binary. I'd be able to go look in the prefetch folder. I'd see the binary name with the last 8 of the hash from the directory in which the item executed from, ending in .pf. It only has one of that item at a time. So if I execute it, command.exe right now, and then an hour from now, executed command.exe again, I would only have one entry of command.exe in there. I could utilize third-party tools that would be able to give me a little bit more verbose data and tell me the number of times that command.exe was executed. But from a live machine, that's a very quick and dirty analysis of sorts. Now, that's not what its true purpose is, but from a forensics analysis perspective, we can absolutely take advantage of it. From a red team, I don't want that enabled, so I'm going to go in there and we can get rid of that by disabling it. All right, you may have noticed on your Windows machine, you have SVC hosts running. You may have 5, you may have 15. Each one of those SVC hosts are tied to either one service or a multitude of services. Services that are running in the context of SVC hosts. And they're running in a sort of groups, if you will. So in this case, I'm able to go to the SVC host key and I see these groups. One of the groups is called Net Services, Net SVCS. And within there, I see highlighted in blue all the services that run in the context of that group that runs into the context of SVC host. So I just added in at the end one called helper. Helper is one that I made up. And then within the registry in another location, I could see all the services. So we see the service helper, and within there, I see where I pointed to a DLL called demo DLL. So now when I start that service that runs under the context of net services, that runs under the context of services SVC host, my DLL will now execute. Luckily for us, in this case, my DLL does nothing more than presents a GUI or a window to the screen saying hello world. All right. But again, I'm now going a little bit deeper. If somebody were to just try to analyze processes, this would be an instance in which I'd be able to fly under the radar. We also have some stuff within Microsoft Office. When we start to debug programs, we can see in some cases programs calling upon items and locations that don't normally exist. And Microsoft Office had this actually happen where it was looking for a perf key, and it will load whatever's in there. So understanding that, the same thing, I created the key, created the location, hit it with my demo DLL, and now I'm able to have Microsoft Office load that DLL on my behalf. We can also hide data in here. We talked about this kind of briefly with the base 64. So in the back of your mind, you might have been like, well, I'd probably notice a whole bunch of base 64 sitting in the registry. Maybe you will, maybe you won't. The registry is huge. Now, if as an attacker, I thought somebody would find it, well, I would go in there and I would pad it, right? Notice how I see the base 64 there. Instead, I would just pad it with a whole bunch of white space, essentially. In this case, I did it with 160 blank characters. And then I also had it say value not set, kind of like what it does with the default value up there. Now, you'll notice all the way to the right of that line, I have the 3 dots. If you were to double click on that, you would open up the data associated with that value, and you'd absolutely see my base 64 code. But I'm going to take my chances here. 1, I don't think you're going to find my code in the registry. 2, if you think you're going to find it, then I would just pad it, making it a little bit more difficult for you to do. So it's really a cat and mouse game from a red team perspective in there. All right, so as we wrap up with just registry, when you run something like system info from the command line, and you're getting all this data back about the system, we can nearly get all of that back. There was only like one of them I couldn't find within there, right out of the registry, and we see those locations as well. Running system info from a red team perspective could be an artifact. Hey, I see somebody got on the box, they ran system info, they did a net stat, they did this, they did that, all within 5 minutes. It looks like somebody got on here and did a survey. Or I could just query for specific registry keys that are going to give me that same data, and somebody would only see that I interacted with the reg binary, right? Awesome. Okay, so let's look at actual event logs. And these event logs, well, they're essentially a centralized recording of information about a machine. We have things like software, hardware, operating system, a number of other things. And these event logs can be viewed within the built-in viewer called Event Viewer. What do these things help us with? Well, gives us some indication of what happened, the date in which it happened, the users involved, maybe systems, resources allocated. And from a location perspective, we see that they're located in system 32. In older versions of Windows, we would see them in the config file, config folder rather. That's the same location that we would see those registry hives. In modern versions of Windows, we would see them in the Win Event folder within system 32. They've also changed their extension to be EVTX. So the types of logs, we won't talk about all of them, but some main ones here. Security. This is the main one reviewed for forensics. You got login information. You got a number of other things that are happening. Process creation, if that's enabled. File access, failure, success, a number of things. We have application and services, and these things are going to largely deal with services on the machines and programs and other applications that we may utilize. Now, there's a good long list of event logs. I implore you, encourage you to go look at them and really understand which ones are most relevant for you. If I were to only be able to pick one, 4688 process creation is going to be my go-to. It's not enabled by default, but if it is enabled, that's the one I want to roll with. All right, some other interesting logs that may be good for you. If you're in an environment that doesn't allow you to use removable media, well, you'd be able to see that as well based upon the event logs when people plug stuff in. If you were interested in a particular application, or maybe somebody disabling or removing it, maybe a malicious guy was doing that, we'd be able to see that with those specific event IDs as well. Let's look at something like 4624. This is going to be a successful login. This log is just an example of other logs, but other logs may have the same characteristics. So for example, a 4624, it may tell you that Fernando logged on, but there's also log on types associated with that log to depict how I logged on. Was I interactive, meaning I was in front of the console? Was it a network log on? Was it something like a batch log on? Probably indicating something like a scheduled task, or I accessed via a network share. Was it a remote log on like RDP? Right? All of these things are important from an investigation perspective because we're trying to tie a actual person to the persona at the machine, or we're trying to understand how it was authenticated. So every other log has some other enrichedness that's associated with it as well, but not all of them are the same. This is only applicable to the 4624 log. So if we wanted to locate the relevant logs, we need to be cognizant of our architecture and our infrastructure. So if it's a domain system and it has things to do with domain authentication, we'd find those logs on the domain controller. If it's an actual system and then we're remoting in, then we would find those things on the actual machine that we're remoting in. Network share, again, is going to reside on the system that's managing the actual share itself. So understanding where these artifacts are enable us to go to the machine and do the analysis at the machine in which they would be resident. So looking at the event logs, we got the event viewer that's going to be built in. We can look at online or offline logs in there. We have Event Log Explorer. That's a tool that's available for download and install. We have PowerShell, of course, that's going to allow us to do online and offline logs. We can read them remotely as well as locally as well. We also have the ability to do some custom logging, right? Maybe that red team guy gets on the box. He understands what's available event ID wise for Windows, and he seeks to do a survey to understand what you have enabled before he does his follow-on actions. If he doesn't see certain things are enabled, he may feel like the coast is clear, and he may conduct those follow-on actions and bring additional malware. So with custom logging in PowerShell, we have the ability to log the things that aren't being logged. So in this case, I just created something that logs Notepad being run, and I put in the event ID that I made up, 1337. Now I'm storing this in the application log, and I'm able to fill it with whatever data that I think is relevant. So triggers from the event log may be something like post exploitation, maybe something like persistence, and we can monitor for particular events. So in this case, we have something like this, where I'm looking for a person every couple of minutes or so, right about 5 minutes. I'm going to retrieve the event logs, look for something of importance that I care about, and if it's in the event log, then I'm going to have it do another action based upon that. Again, if something of importance for me is found in that event log, then I'm going to do something that I want to do following that. So in this case, we just have it loop through. Roughly every 5 minutes, it's going to grab the event log, look to see if the event happened within a particular period of time, and then see if it contains the administrator. If it contains the administrator, then I'm going to kick off another process that goes out to a website and downloads something for me. So this is just an indication of how we can have triggers or actions that happen based upon particular events within the event log. All right, and then we have the ability to clean up, right? So if I'm red team in nature, maybe I messed up and something logged that I didn't know was going to log, but I don't feel comfortable leaving it there because there might be a chance somebody would see it. So we have invoke ghost log. It's a thing that I wrote to be able to alter the event logs and remove items that we otherwise would not have the ability to remove unless we remove the whole event log at large, which we're not going to do. These queries would be based upon XML. So we use some XML querying in the event log so we can array what it is we're trying to get rid of. And then we would feed that to the invoke ghost log program. I can do this based upon individual event IDs or a time frame or a combination of both. Now, the thing that I have to be cognizant of is when I do this, an event ID 1100 is going to kick off, essentially saying, hey, somebody disabled the event log service for a period of time. And unfortunately, this is going to require system level rights. But let's walk through this. Okay, so I have my event log security, and I'm going to come down and somewhere up in here, I have where I executed a demo beacon.exe, right? And I'll just make believe like this was a red team tool, and I didn't know it was going to log, and it logged. So what I would do is I need to get some data, or I need to arrange essentially an XML query that I'm going to feed my actual tool, right? And this is going to be essentially time framing or essentially what I'm trying to remove. So I've already fast forwarded in the sense of what my query should look like and did it. And I would have done it in here, a custom XML. That's a video for another day as far as trying to make it. But the short of it is, this is the XML I needed, right? So I have my security log that I'm selecting. And then what I'm suppressing essentially is the ones that contain demo underscore beacon in it. Okay, so I'm going to feed that to my program, and it will essentially go through and wipe that out for me. So I'll come back in here. Again, I needed to be system, so I'll verify I am indeed system. I'm going to come in and dot source, essentially read in my program and make it usable for me. Right, and okay, and what it wants is the actual log. So I'm going to do the security log, and then I'm going to say what to include, and I'm going to include everything. And then I'm going to say what is it that I'm cleaning, and then here is where I'm going to feed it that line from my text file. Again, I would have used something like the event viewer, did a custom filter so I can get the XML. I probably would have done that on my attacker machine, not on the target. Understood the XML structure for what I needed. And then on the target, I would have executed invoke ghost log the system, and I would have fed it essentially the query part that I need to then isolate and say, don't include that. In this case, event data, where data includes demo beacon. All right, so I'll run that. Invoke ghost log will do its thing. And then once it's done, I'd be able to go back in there and look at my security log. And what I'll notice is that item is gone. So we'll come back down, and that was something like 11:02 on the 27th. Or 11:01, I think, 56. All right. But we notice it is gone. If I were to click on it again, that log is gone. That was a 4688 process creation, but notice all the other process creation logs are still there. And the one that I was worried about is now gone. All right, awesome. So that's invoke ghost log. Again, the artifact I get from this is an 1100, but that doesn't necessarily tell me that somebody actually altered the event log, other than the service just shutting down for a period of time. But notice how quick that was. It was down and up. Ghost log did its thing in the background, as long as I fed it exactly what it was that I was trying to clean up. Okay, with that, that brings us to the end. We talked about a large amount of artifacts in the registry and event log. We talked about some things that are useful for a blue team member, red team member, and really somebody who's doing a little bit of both. If I do blue team activities on a daily basis, it's good for me to understand what are things that a red team member would be able to affect in the registry to stop my analysis. If I'm a red team member, it's good for me to understand what in the registry the blue team member would be using to help his analysis so I can then either step on it or try to avoid it. We barely scratched the surface with a lot of things that we can do, but I would tell you, these are core things from a Windows perspective. Their artifacts are huge. You just have to know where to go to look for. If you're interested in this presentation, you can find it on my site at the location listed there. If you're interested in both Ghostlog, you can find that code along with other code that I've written on my GitHub. And if you just want to connect, you can find me on Twitter. I'm always looking to interact with people who are like-minded, have the same goals as I do. With that, that concludes my talk. I really appreciate the folks that put this event on today. I wish I could be there in person, much like everybody else, but nonetheless, thank you for the opportunity. I look forward to interacting with you at another time. Thanks.